everyone to our webinar, Prepare for a Career in AI as High Schooler. I'm Dr. Amy Morgenstern, and I'm founder and CEO of Blue Stars Admissions Consulting, and I'm here with Ross Greer from Polygence, and I will give him a full introduction in one moment. And what I'd like to do first is just talk about our agenda very, very quickly. Wanted to welcome you. And I will give you an introduction to Ross's work in AI. Ross and I will talk for maybe about 20 minutes or so, and then we're going to open things up for Q&A. And I'm sure you have a lot of questions, and we are ready to field them. We're excited to see what kinds of things you're curious about, what you want to know. So fantastic, excellent. I just wanted to give a quick introduction to Blue Stars. So here's our excellent team: Helen Ingerson, Jennifer Turfler, and Eliza Cohn. We're a multi-counselor consultancy, and our motto is personal growth leads the way. And we feel that when we work with students from the inside out, helping them with their time management, their confidence, their decision-making, and then, of course, helping them with defining their interests, activating their interests, learning how to contribute to the world, all those things happen so much more successfully. So we work with students starting anywhere from 8th or 9th grade up through college admissions. And we also work with art students, but we do work with students, interested in every subject. So, okay. We love Polygence. I've known Polygence for a long time now. Years back, I first met Jin Chao, the founder or co-founder of Polygence, and we've had students working with Polygence over the years, and it's really improved their success rate and admissions. And again, it's really significantly contributed to their personal growth. So as you can see, Polygence turns ideas into reality. It is an online mentorship program that helps students turn their passions into unique research projects, a totally interdisciplinary service. So students work with PhD level mentors who design experiments, they'll build robots, create podcasts, write original screenplays, or publish in peer-reviewed journals. So all sorts of subject areas, and it's really made a big difference. So as you can see, we have a partnership with Polygence, and we have a designated page. And I can just tell you that when students are starting to really get into their 10-week mentorships, you start to see them glow. And then once they start to report on what they're doing, it's almost like they're realizing how much they've accomplished while they're reporting it, because when they're in it, it seems like so much work and they haven't met their goal yet. And it's a really great addition to one's activity list in high school. So yeah, we've got our own page. And now for our special guest, who is a Polygence mentor, as well as a PhD candidate at UC San Diego, I'd like to introduce you to Ross Greer. And I'll just read his bio because it's intricate and impressive. So give me one moment to savor it. Ross uses AI to develop human-aware systems for intelligent vehicles, virtual classrooms, and concert halls. He also works at two labs: the Laboratory for Safe and Intelligent Vehicles and the Center for Research in Entertainment and Learning. His research focuses on predicting vehicle trajectories, assessing driver readiness, interpreting human gaze and gestures during live performances, and using AI to teach computers music composition. His ultimate goal is to foster AI co-creativity services in the San Francisco Bay Area, and we will have to unpack all that means. And welcome, Ross. Thank you so much for joining us today.
Thank you. Thank you.
And I just want to say, I'm going to unshare my screen so you can see actual larger heads talking to each other, and then I'll probably reshare it later. Yeah. So did you want to just give us a more of elaborate on what you do, and then of course what that ultimate goal of yours is?
Yeah, I'll elaborate a little bit on that, and I think perhaps that last sentence could be updated to really say my passion is to teach other people about AI, really, and so the goal of all this, producing research and exploring these great projects, is really to start to let AI interact with more and more people, and then also for myself, I'd like to be teaching one day and continue sharing the word that way, in addition to creating these research projects that interact with people instead of just other machines. So a little bit about the two labs that you saw on that page. What's really unique about our laboratory for intelligent and safe automobiles is we are not an autonomous vehicle group. If anyone here is an enthusiast of these upcoming AVs, you've probably heard of the levels of automation. We have level 1 where the human's driving the vehicle the whole time. You have level 5 where the vehicle is driving itself with no intervention. But the reality today is that we live in a level 3. We're in this in-between space where even the best cars still need the human to jump in and take the wheel when they're about to hit a construction worker or a cone that isn't part of the regular driving routine. And so we build systems that look outside and inside at the same time. They look outside and see where the other vehicles are going, what signs are important, and we try to relate those to the people inside the car and the societal norms we built on what it is to drive. So things like, are you going in the right direction for your lane? Is that stoplight talking to your car? Should you be aware of that sign or should you ignore that sign because it's for your outside lane? And so that's the outside looking part, but we also look inside at the driver because we still need to understand, should that sign be confusing to the car? Is the driver ready to take the wheel and slam on the brakes? Or are they halfway through their book? Are they falling asleep? Are they midway through a text message? Have they been drinking? And with these decisions, the car can be a little bit more intelligent and safer for everyone since it's aware of both what's happening inside and outside the vehicle. So that's half my life. And the other half still involves people because I like to look at people who are performing music or generally being creative with AI systems and look at how we can better pass messages between the human and the machine. And I think with ChatGPT being the most popular thing in the past year, we've all had the chance to start to interact with AI a little bit more on a personal level, to be creative, to ask for help drafting an email or writing a short description of something. And so being able to give feedback in a meaningful way is not easy to do and not really a scientific method yet because this is such a new space. So some of my work is in that area.
Awesome. So interesting. And it seems that what you're doing is, I mean, I guess AI could be considered H, the human-computer interaction, but it sounds like you are doing artificial intelligence with also human-computer, that interface as well. So it's both the AI, but it's also the interaction.
Yeah, I'd strongly agree with that because there's a need to codify and mathematify all of the social norms that we've built into how we communicate, gesture, make eye contact with people. All those things should have meaning for a system that's going to operate with humans. And so there is a need to turn that away from necessarily being a social science and thing that's studied, but also integrate that into the actual loss functions that drive these machine systems, the reward systems that drive them.
These are two very divergent areas. Do you see them that way, or do you see them interconnected? So the autonomous cars.
I see it all connected through this lens of passing high level abstract symbols and building systems that recognize them. Because at their core, these systems are bodies of sensors. They're microphones, they're cameras. And at some point, we have to work up this abstract pyramid of thinking where we're not just pulling in pixels and light and sound. We need to turn these into human level symbols. And the machines are doing that to learn to recognize cats versus dogs. They're learning what sets of pixels make an eye, make an ear, make a mouth, and oh, that's a cat. There's other ways we need to work up that pyramid that involve passing messages between people and understanding intentions.
It's so interesting. I live in San Francisco. So, now I hear that there are tourists coming to San Francisco to go for a ride in the Waymo.
Yes, I was so happy when I finally got off the cruise wait list, but it was the day I was flying back from the Bay down to San Diego. And so I haven't had my trip yet. I'm really looking forward to it.
It's a thing out here. So tell us, how did you get into all of this to begin with?
It's been a pretty long path for me. I actually didn't know I wanted to do this from day one. For me, coming out of high school, I was your typical student taking a few AP classes, figuring out what college major they might like, and I thought physics was the answer for me. So I went into my undergraduate degree thinking I'd be a physics major, and then I took a computer science class, and I went, "Ooh, I can't really let this go. This is pretty fun." And I kept stringing along both until the very end. And then I realized right after I graduated, physics is probably not the answer because I went to go tour some labs when I was looking for a master's program. And they had me looking at a microscope, watching crystals grow, and I thought this is very inspiring but pretty boring for me, and it was not the right answer. And so I took some time off of school to, well, I wouldn't say soul search, it was to work in a job that turned out to be not what I wanted to do. I was doing some supervisory control and data acquisition engineering, which sounded really cool. And then I was just not feeling this type of software that's so impartial and there's no people involved, there's no excitement, no curiosity. It's so routine. And so I did my real soul searching once I was bored with my job and went, okay, when was the last time I enjoyed this? Eighth grade robotics club. That was my answer. And so I grabbed onto that memory and I'm like, okay, well, let me look at some master's programs in robotics. And that brought me to UC San Diego back in 2018, 2017. I started my master's. And then in that program, I took my machine learning classes, my AI, and I met a really inspiring professor who ended up now being my advisor and really just fell in love with this world of computer vision, AI, understanding the world through the lens of a neural computer system. And I've been at UCSD ever since.
Thank you. So one of the takeaways for me too is it's not always a straight and narrow path, even though we are talking about how do you prepare directly for AI, we'll get to that. So and eighth grade counts.
Yeah, definitely.
Right? What's it about AI that really drew you and you just couldn't let go of it?
For me, it was the moment when it clicked that we're actually making these computers replicate things that we do. And so it was the balance of learning about how our bodies work and then seeing that you can actually create small scale things of those. So when I understood that our eye is actually just working the same way a camera works and the way that we form an image on our brain is the same way that we implant that light on the grid and then turn those into pixel values. That was so cool. And then understanding that when we see little edges in the way that we might, recognize something before we consciously react to it, that computers can process the same way and taking these edges and combining those to look like a circle, and that circle matches with another circle, and now you have a face. All these levels of processing were really inspiring to me because it made me have a greater appreciation for what it is to be a person, and then also to translate that to, okay, now can we make a computer do this?
So what would you say are the top three innovations, most exciting areas or spheres for AI?
Wow, that's a very hard question.
I
So
ask a lot of top three questions.
I definitely need to say these large language models that we've been enjoying over the past 2 years or so now. This is pretty unprecedented that we can have these machines chat with us in this way, and also has opened up a whole new field of questions about back to what it is to be a person. Is something that just echoes and reflects back our language to us, is that thinking or is that not thinking? And there's a lot of hot debate on that I won't talk about right now, but I think that's a really cool area and inspiring. I also think we're getting pretty close to seeing the autonomous vehicles operate in a much safer, widespread, and available way. I think it's only a matter of time as we start to figure out how to map cities correctly and start taking these rides and getting some more test data in. So I think that's number two of an exciting thing. Number three, I'll have to think on. Maybe I'll come back to that with a third answer as we keep talking.
Well, top two is always good. So, and that's, again, these are the places where, students might be thinking about, like when we work with high school students, what we call definition is really important. So I love physics, I love AI, I love computer science. Well, we need to dig in there and get more specific, which is a big reason why we love to partner with Polygens, because it helps students get into that specificity while we're working on like parallel processing on other things, So it's really helpful even just to hear two, and they can start to think about that, so.
I did think of a third one, which I'll jump in with
I'd
actually,
say,
is I
yeah.
saw a great commercial 2 days ago. It was a French commercial for to get more people to come watch soccer games. And they showed this highlight reel of these people doing flips as they're kicking the ball and then getting the header at the last minute and amazing saves. And then they paused the video and did a screeching soundtrack, and they showed a programmer who would replace the head of each player and the jersey number with a man. But this was actually all the women athletes in France. And they were actually drawing people to say, actually, you want to watch women's football, not just men's. And it was a really, really cool use of deepfake because they had everyone completely buying into the wrong perception for a moment, and then whipped the veil off and showed who you can really be fans for. It was really cool. So I think balancing deepfake technology, very scary right now and very harmful, but finding great ways to use deepfake, I think that is another exciting area of AI.
Again, playing with perception, and I do want to say, just as an aside, we'll get on topic one more second, but on the idea of, is it thinking? My specialization is philosophy, so maybe one day we can sidebar on that.
Yes.
I have a lot of questions about that. As someone, I do use ChatGPT. I explored it in a variety of ways. I love tech. I listen to a lot of tech podcasts. And so, I've been on it, using it in different ways. And I have to tell you, with the students that we work with, our mentees, a lot of them, I'll just, ask, so you are using ChatGPT? And the answer is either no or absolutely.
I'm on team absolutely. Every day I use it for everything from coding to writing or having a tricky social situation I want to think through with a friend and then just bounce it by and let it talk to forums, decades of forum knowledge from the internet.
I don't know if I should admit this, but if anyone sees the emojis in my emails, but and I've learned so much about it using it myself. But I just wanted to point out there's either very negative or very positive.
Mm-hmm.
So I found that to be a very sort of interesting set of results. So how would you describe like the main types of careers in AI? And I know careers are going to be continually changing, of course, but the students, the people in our group today, they might be anywhere from 8th to senior level in high school. Any
Yeah,
thoughts?
definitely. So there's a lot of different parts of an AI system that I'll try to cover broadly here. That data feeds the ability of these systems to learn. So there's a ton of work done to build the infrastructure and manage the collection of data so that these models can be trained. And so there's a whole widespread variety of careers in that area, which is just how do you manage data? How do you collect, curate, annotate data? Then you also have teams of people who manage the usage of that data. So maybe you're not actually the machine learning engineer who's building the system, but you're the person building the components that reach into a giant database, pull the right records, pull the right videos, pull the right audio clips, and provide those in a usable format to the machine learning engineers. And you're still part of this ML group. You're the ML ops of this. So you have your data collection, you have your ML ops, you have the machine learning engineers themselves who might be given a task. Maybe you want to build that dog cat classifier, and you're the person who gets to run thousands of experiments over all the possible what are called hyperparameters for that system and try to figure out the most optimal blend you can get for great performance. And then you have the system designers who are thinking about, okay, what architecture is suited to solve this problem? We look at cats and dogs with our eyes, and maybe we need to be looking at color images because color plays a huge part in this. So our architecture is going to be 3 channels of an image coming in, and we'll have this many layers of depth because it's this complex of a task for people to do. So maybe we'll have the computer replicate that. At least I'd call them system architects. And on top of all that, the part that I'm most fascinated by is the researchers who come up with the questions to begin with. They say, okay, is it possible that an AI system can distinguish between a cat and a dog using just 3 seconds of audio from a room they're sitting in? And these people come up with the research questions and then the experiments that must be carried out to answer that question. We also left off the whole production team, right? If you're building your autonomous vehicle, you got to then get that car out on the road. So you need people who are going to port that system and make it lightweight enough so that that model that took 30 seconds to run on your computer can happen in 1 second, so it can make quick processing and see the pedestrian in the road in front of it. So I guess what I'm saying is there's an infinite number of directions and careers within this whole AI space. And broadly, what I would say is where you kind of want to cut off your education depending is that if you're looking for a role in that data collection, acquisition, and maybe infrastructure side, I tend to see that be peers of mine who have they've worked really hard and then they get their BS degree in computer science or a related field, and then they have all the skills they need to excel at a job. If you want to get into the ML engineering side of things, you usually need a master's degree because what you'll cover in a 4-year computer science program, there's just not enough time to get into the mathematical details of what an ML system is and how to build one at a managing level. Mm-hmm. And then if you really want to do the research side, like I do, you got to keep pushing for that PhD because you have to actually understand how to formulate these problems, all the different solutions that comprise what we would call the state of the art at a given time, and being able to leverage and use, okay, this solution makes sense for this problem. That takes a few extra years of experience to get there.
Fascinating. So it runs anywhere from like software to hardware. Obviously, you got your start in 8th grade, actually in AI, we found out. Does data science fit in here?
Absolutely, yeah. Data scientists are doing much of that ML engineering part of this, where they're data scientists learn about all these different types of models that can apply to different, what I guess I would just call data types that you might expect. Images, tabular data, spectrograms, whatever you're feeding into a system, a data scientist, after studying, would also know what types of models and architectures are appropriate to pull out information from that data and how to design experiments.
And then on the research side, I'm just curious, in terms of, it seems like you're dealing with so much, dealing with perception. Mm-hmm. So do you also study like cognitive science or neuroscience? Is that a piece of what you do? Or
it's certainly a piece of it. And so I'll just give an immediate example that our biggest project that's underway right now in my lab, we're heavily partnered with the UC San Diego Medical Center, and our co-PI is a professor of psychiatry, because we are doing things that involve the ability of people to be in a driving simulator, and we need to understand their mental state while they're part of this. And we're looking at them from cameras, from audio, but without that type of partnership and shared insights from his decades of experience in this field, we couldn't build our systems, because when you have all this data, you have to be really careful at what features you're going to pull from that to try to run these experiments. And we can get totally off the wrong track if we don't understand that drinking alcohol changes your blood flow and will change the way your face looks, and we build a system that's not leveraging that fact. We are wasting time. And so there's a lot of overlap. And for me, it's fun to get to dabble in classes that are outside of the electrical engineering department. We get to jump into cognitive science and psychology.
And it's maybe you can also like come through cognitive science and neuroscience into AI as well.
Oh yeah, some of my best friends
careers in AI. So I'm just like in preparing, and I'm just curious.
Yeah, we had a joke back during my undergrad at UC Berkeley that a lot of students, they would start off in computer science, and then you talk to them 2 years later and they say that they're reformed CS. And we're like, what does that mean? They go, oh, I switched to cognitive science. And they were taking classes that were much more exciting and interesting to them. And they've all ended up in different software data roles, my closest friends that are pursued that major. And they're most often on these ML teams because that's what they are excited about. Mm-hmm. And you can definitely lead there.
It just sounds so interdisciplinary, and that's what is also so exciting about this field. I'm going to run. I'm not going to run. I'm going to rush. I'm not running. I'm rushing. I'm going to rush through a few things. I want to get to a few nuts and bolts questions because, of course, I've gone over than I said I would. Let's talk about, where does computer sciences in high school fit in? What are the languages you need to know? Where does the Java APCS Java course fit in? How should students be? You also said computer science is one important major. Mm-hmm. how should, starting in eighth or ninth grade, how should students start preparing?
Yeah, I would recommend to all students that you don't think about learning a language. I would say in high school, middle school, you should think about learning how to think programmatically, how to think algorithmically. You're doing that often through Java or through Python as you're learning it. But while you're in classes like APCS and learning to use Java for the first time, your focus should not be on necessarily knowing every function in Java, but rather, oh, this is a for loop, and if I can loop through something, I can check if-else statements. Starting to learn these core principles that then translate across programming languages, because you will end up in situations. You'll be in a class where your professor says to the class, all your homework will be in MATLAB. And if your identity is I'm a Java programmer in your head, even though the reality is you're a programmer, not a Java programmer, but when you think you're a Java programmer, this is going to be a huge obstacle for you. But when you know that, in fact, the same principles that work in Java are the same ones that power MATLAB, that power Python, it's just a way of thinking and translating your programmatic thoughts into a script that you can take with you. So my advice would be for high school students, take APCS and do a little bit of learnpython.org on the side if you're having fun learning how to program. But yeah, expose yourself to the basics of programming. You don't need to rush through a boot camp to master C++ in 10 weeks. You don't need to do that. You don't need to know a language inside and out. You just need to learn some starting algorithmic skills.
So what I'm hearing from you is almost like in terms of like problem solving in math too.
Yeah,
Become a computational problem solver.
exactly. And when I work with students, I usually have to, for half my students, pull them away from their computer screen and keyboard and say, hold on, you're typing all the syntax here, but it's not meaning anything. Here's a pencil, here's a paper. How would you solve this problem if a computer didn't exist? And once you write that down, then we translate that into a program. And then we translate that into Java, Python, C, whatever they're choosing to work with.
I love that advice. And that is sort of something what we do with essays. We'll talk languages, right?
Mhm.
What we do with essays, sometimes you're drafting. Do you know what you're writing? Hold on a second. Get off the computer, let's free write. Close your eyes, even, sort of thing. It's a different realm, but something that's stepping back and getting those fundamentals. So
And that's the most fun thing in mentoring is getting to point out to the student, like, hold on, take a deep breath. What are you actually trying to say?
what is the goal? Right.
Yeah.
Great. Awesome. And I know that you mentor students in this field, right? High school students in this field. This is going to be my last question. I
Sure.
had before we open it up, because it's 7:34 and I want to give people a chance. And participants, please, let me see. Please send your questions in chat. I would really, I'm here. Let me just put in chat questions, put them here, because I'm happy to relay any questions you guys have while we have Ross here. And I had a last question for you, and okay, yes. Well, I mean, if you, aside from becoming a computational problem solver, which I think is a really important piece of advice, and that also could mean learn a few, become fluid among languages too. Is that?
Yeah.
Okay. So besides that, do you have any other most important pieces of advice that you have for students interested in a career in AI?
I would say start from your own interests and your own questioning whether something is possible. I think it's much better that a student, I'll just pick on one of mine here, that wanted to analyze his tennis game using a computer vision system. That is much more rewarding on many levels than signing up for a crash course in how to do C# programming. And you'll be able to take away a lot more from that if you can actually apply things to a problem you care about. And even if you're doing things in what you might think is a simple way and not state of the art, you have to start somewhere. So even just the act for a high school student, middle school student to record a video and then break it apart frame by frame in a program for the first time instead of watching it through their Windows Media Player. Learning these little tricks about how to how to think about data and how to process and manage things that you can pull in from your own sensors, your webcam, your phone camera, your phone microphone. It's a really fun experience and gets you to understand how these systems capture, record, and represent data.
Interesting. Can you tell us about one or two projects you've worked on with your mentees?
Oh, I would love to, because they're really fun projects. I love the Polygent students because they always come with their own interests outside of just getting straight A's in their classes. They also have all these exciting extracurricular activities they do. So I have one student that loves to play the flute, and he is deciding right now between auditioning for conservatories or studying computer science for his college major. And so his project he chose is that he is taking recordings of professionals, amateurs, and everything in between on a well-known audition excerpt. And we are looking at spectrograms of the audio and then feeding them to neural networks, hooking up the network output to ChatGPT, and we are basically giving, after you play a recording, a thorough description of what could be made better in your audition and what rating these AI judges have given your performance. So much fun and completely aligned with the students' passions.
Again, what is possible, right? Thinking about
Yeah.
what's possible and getting those pre-critiques. That is incredible. Cool. And I love, again, the interdisciplinary, because, we have students, we work with students who are creative, we work with students who are STEM, and sometimes they feel like they have to decide. And what I like to do with students, I have them combine things. I'm like, you don't have to decide. And this is an amazing example.
That was the best piece of advice when I was going through finishing my undergrad. My band teacher, he's like, oh, I was like, I really like music. It's kind of hard to feel like I'm pulling away. He says, you can always do both. This is when I was going to be a physicist. He says, look at this past student we had 10 years ago, and he went and studied, he was, I don't know exactly his research area, but he was combining physics and music in a way of doing spectral analysis of recordings. And I was like, okay. He's like, you can do both. Don't feel like you have to do one thing. And I thought that was nice advice. It's the advice I wanted to hear, and I stuck to it.
Well, I'm glad, because that is a main piece of what we do. And the students, they feel torn by these existential decisions. And I'm like, no, you don't have to be torn. You really don't.
Yeah.
And you can be torn later. Right now you can enjoy all these things because it looks really cool for college, among other things. So we do have a question. Thank you, participant. And please, everyone, feel free, whatever questions you have. And the question is, can you explain how AI applies to robotics?
Absolutely. So robotic systems have to perceive the world around them and make decisions and move their joints in that world. And every component of the system is littered with noise. So perceiving the world, you're going to have sensor issues. You're going to have little salt and pepper cracks in your image. You're going to have a little jitter of your robot that's not where you expect it to be, that's going to change your vision system point of view. So building systems that can take in a noisy world and filter out and dismiss that noise to perceive the meaningful, important parts, that's all AI right there, because these are all systems that need to accept a world that has the real symbol plus some noise, and then make a decision on what is what. And even for movement of robotic joints, a lot of this is using learned relationships, because it's very complicated when you have these multi-joint systems to program every little aspect of that to get it to go in the ideal path. It's a whole different system if you can grab the arm, move it here, teach it a pattern, or even give a result-driven performance. So let's say you're building a robot that's learning how to sort fruits, you put apples in one basket, orange into another. That system, sure, you can program it exactly what an apple is, how to pick it up, how to place it, or you can just say, try to do something, I'll tell you if you get it right. That's the whole basis of reinforcement learning. A huge area of AI is you try something and the environment gives you some reward for how well you did at the task. And so if you don't study learning systems, you won't be able to implement those systems on robots. And robots are not just hard-coded these days. You don't just give it a set of instructions. They're entire learning systems, from perception to control.
I wish I can remember the podcast I was listening to, but there was a lab where they talked about the AI robots have just totally changed everything. I think it was Hard Fork with Casey Newton. So I listened to more of like more the popular and less technical, because I'm not a technical person, but he's a tech reporter, and they went to a lab with AI robots, and it's a game changer. It's a total game changer.
I'll have to check that out. Yeah, I have another student project related to this that might be
Yes,
a little bit
please.
motivating here. That the when you picture the robotic surgeries that happen, sometimes a human needs to intervene and do part of it, right? Because there may be some maneuver that's too complex for a robot hand to do that only a nimble human hand can take care of. And being able to identify that moment for the handoff is critical, because if the robot thinks you finished early and goes to grab the needle and you are still halfway through whatever you were starting to stitch, that's going to be catastrophic. But also, if you're left waiting with your hand up, you're like, robot, I need you to grab the needle, uh, you're going to now leave the person on the operating table longer than they have to. So being able to identify these changes, there's papers on this that use hidden Markov models, which is a huge area of machine learning. And without these learning systems in place, you can't really interact with the world in a way that is ready for how variable the world is.
Interesting. Cool. Did you want to talk about another project that you worked on with a student?
Um, I can. I just saw another question pop up, but one more student project I can bring up while we're at it. I had a student that was looking at basketball. They were building a system that they could put their camera on the court, watch them take basketball shots for free throws, and then count whether it was in or not, and also look at the angle at which they shot the ball, their whole shooting pose, and then give them feedback. And all these ones that combine sports and AI, super fun. And there's whole conferences dedicated to computer vision in sports. So whenever a student is like, I don't think I can do that, my parents wouldn't be very happy if I was just studying sports for 10 weeks. I show them, actually, there are people that study sports for 10 years with computer vision and make whole careers out of it. So, don't feel scared.
Last time I heard, the sports industry pretty lucrative.
Yep.
So again, we have an athlete on, and I'm like, let's put, so they're cool, very, very interesting. So we have another question, which is, where can you learn to do AI?
The best place to learn to do AI is, in my opinion, late undergrad or graduate school. If you really want to learn AI in a comprehensive manner, where you're thinking about not only the applications and how to program, but also what is the math driving it, what is the history of sensing and perception that led to these developments. So that's my best answer. But if you wanted to learn a little bit while you're finishing up high school and start to build some of these projects, there's a few places I would recommend. Towardsdatascience.com is a site of blog posts, and these people are most often just seeking to share for anyone to read and understand and re-implement on their computer how to build systems. So if you find some good blog posts there, you can tell when you start reading it if it's a good teacher or a sloppily written article, and many of them are high quality that I share with my students. I say, check out this article. It's exactly what you want your project to do. So a good search there is helpful.
Can you put in the chat, Ross?
Yeah, certainly.
Thank you.
Towards Data Science has a great set. There's also, I'm struggling to remember the name off the top of my head. There is a computer vision and digital image processing dedicated blog that now has multiple content creators and shows really cool vision systems. Like if you wanted to make a little mini security guard camera for your bedroom, just to annoy your siblings and your parents. And it will come to me in just, oh, it's Pi Image Search. That's the name. Check out Pi Image Search. They're all very approachable Python projects that a student could get a start. And then it also motivates the need when you build that camera system and you go, it detects my cat 80% of the time using this method. Why can't it be better? That's when you start going, oh, they mentioned in the comments, you could use this AI technique to make it better. And then that'll hopefully inspire a student to dig a little bit deeper, learn a little bit more, and try some new things. The last thing I always give a shout out to is learnpython.org. Back when I talked about just building those beginning programming skills, if you can get through that website, which is it's free and it's very comprehensive on the basic building blocks you need to start building AI systems. So I point students also there.
Thank you so much. And we will put that one more excellent question. We'll take one last question, but we will also put those resources in our follow-up email and the links to that. So thank you for those excellent resources. And one last question, and then I'm going to just get to the next slide and show the Polygen's contact info. But do you have to know how to program to learn AI?
You don't need to know how to program to learn how to think about and appreciate and use AI systems in the same way that you don't need to play an instrument to go enjoy a concert. But I would say you need to know how to program to build systems of your own and to experiment and to fully enjoy the system. So I would say you don't need to, but to really learn it all the way through, you would need to pick up some programming.
Awesome. Thank you for this sage advice, these amazing resources, these excellent stories, and for your valuable time. It's totally appreciated. And if anyone is interested in working with Polygens and doing that, 10-session mentorship, they also have sort of shorter programs that help students with career exploration. That is also like in our language, helps with definition, helps students try to think through what they want to do in the future. So here is Maureen's information. And I just want to note to everyone that we are having a sale for the month of October. So there's 10% off for the month of October. So if you are interested in services, we hope you get in touch. And once again, thank you, Ross, and thank you to everyone. I hope this was helpful. And we will have the recording ready for you guys in a few days. Have a great night, everyone. Take care.